A terrifying openness made by the James Webb Telescope revealed what had all the stores of being city lights in space. Found 7 trillion miles from Earth, this crucial finding has touched off interest in the possibility of extraterrestrial life. The telescope zeroed in on Proxima Centauri b, the nearest exoplanet to Earth, revealing unusual, splendid lights sending from it. What could be the justification for these city lights on Proxima Centauri b? Could this show the presence of life? Join us as we dig into how the James Webb Telescope recognized these amazing things in space. For quite a while, trained professionals and people at large have speculated and researched the possibility of life beyond our solar system. Any confirmation seen to back up the space dream has been welcomed enthusiastically. Scientists were paralyzed when verification of living things existing in space was seen by the James Webb Space Telescope while researching space and sending information back to Earth. The James Webb Space Telescope saw odd city lights gleaming from the exoplanet Proxima Centauri b. These lights, as their name suggested, appear to illuminate a far-off city. The chance of an untouchable city existing on the star has left researchers in shock. They are puzzled, since this could be the presence they've all been waiting for. If this turns out to be true, as many believe it could, it suggests that intelligent living things are building developments unknown to what humans know in space. We are just beginning to believe that it is investigating the city lights seen 7 trillion miles from Earth. NASA engineers can't help but wonder how long these lights have been sparkling in space, waiting for humanity to develop the technology needed to recognize them. David Kipping, a space expert from Columbia University, describes the Proxima b exoplanet, where the city lights were found, as dazzling. He said so because this star system, closest to us, has varying heating patterns that differ from those of other planets. The normal rocky planets are known to absorb light and emit infrared radiation, but not for this exoplanet, as its infrared nature is entirely different from that of its host star, Proxima Centauri. This clues at a crucial observation by the James Webb Space Telescope, JWST, which is capable of perceiving infrared frequencies. The distinct heat signature of Proxima b will play a key role in uncovering the planet's environmental mysteries. With the latest technology in infrared imaging, researchers plan to utilize the JWST to uncover the secrets of its climate. They also hope to use the telescope to assess the potential for life on this exoplanet. The James Webb Telescope has infrared sensitivity that can examine what happens on Proxima Centauri b's nighttime side, detecting even the smallest light emissions in the vast darkness. This is generally very difficult for space telescopes, but not for the JWST, which can detect even the tiniest light emissions from space. It is the ideal tool to check if the rumors about city lights on Proxima's nighttime side are true. Any artificial lighting in the universe can be detected by the telescope as long as it falls within a frequency band, often smaller than starlight. Proxima b has a fascinating connection between its heavenly components and surface features. The daytime side of the exoplanet contains numerous solar panels that absorb the bright energy from the star. Its spooky edge also reflects incoming light beams. Simultaneously, when Proxima b completes its orbit around its host star Proxima Centauri, it experiences steady periods, similar to those on Earth. During the day, it experiences high solar heat, while at night, it cools off. The planet is known to have fluctuating temperatures, still not entirely set in stone by its arrangement. For instance, if there's no atmosphere on Proxima b, the contrast between its day and night time spans will be very quick and extreme, without the controlling effect of atmospheric gases. The temperature on the day side will be very hot, and the night side will dive into cold darkness. The degree of temperature variation is a critical subject for space scientists to unravel. A deeper understanding of Proxima's environment with the JWST's unparalleled infrared imaging capabilities will enable effective analysis of the planet's heat emissions to provide valuable information about its atmospheric properties. Curiously, the orbit of the James Webb Space Telescope around Earth aligns with Proxima b's orbital period, considering intensified observations of its day and night cycles within 11.2 Earth days. Since Proxima b does indeed have an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can support life. Key signs of something occurring beneath the surface include the presence of gases like oxygen, water vapor, and methane. If these elements could be found in the atmosphere, it would suggest habitable conditions. The process of determining this requires experts to be cautious as they capture and analyze light beams passing through the planet's atmosphere. This is a challenging task to undertake, even with the JWST's exceptional capabilities in characterizing planetary environments. While powerful, the James Webb Space Telescope doesn't have unlimited capacity and can only peer at a few of the nearest possible worlds to conduct in-depth environmental evaluations. Space specialists are now looking toward ground-based observatories like the Extremely Large Telescope, ELT, which is set to begin operations in 2028. The ELT is designed to test the atmospheric composition of distant exoplanets and will provide data offering in-depth insights into their habitability. NASA specialists and the public eagerly anticipate the development of future space telescopes like these. Until then, the James Webb Space Telescope remains an essential tool in our mission to uncover the secrets of distant exoplanets. Despite its current limitations, the JWST has the potential to provide significant insights that could revolutionize how we understand exoplanetary exploration. Experts have set a goal for future space telescopes to reduce the amount of bright light coming from a planet's host star, allowing space specialists to better see the light reflected from the planet itself. They plan to do this by using inner shields or large outer satellites shaped like an umbrella, similar to using your hand to block out sunlight. Reducing the harsh brilliance from a host star will enable future telescopes to shine a light on faint traces of light from a distant exoplanet, allowing for a more thorough assessment of its atmosphere and the possibility of supporting life. However, this comes with its own challenges, as researchers must differentiate between gases produced by life and those from geological processes like volcanic activity. Space specialists are not giving up on understanding the characteristics of exoplanets to better detect signs of life beneath the surface and distinguish them from false positives. The Webb telescope represents a glimpse of scientific progress in exoplanet research, offering a preview of the extraordinary discoveries we have yet to make. As we expand our understanding and exploration of the universe, we are better prepared to grasp the complex dynamics of the universe and our various roles within it. In the wake of searching all the planets in space, researchers have yet to find one that harbors life. Despite many years of searching through space for signs of life, the mission continues. We alone in the universe for a really long time. People have contemplated whether they are the only ones in existence. This well-established longing actually continues today, even at this point. Specialists have the James Webb Space Telescope in space, endeavoring to identify extraterrestrial developments concealed among us while reading up on different planetary bodies for indications of something going on under the surface. Simultaneously, a well-known hypothesis has arisen recently, recommending that a few extraterrestrials could genuinely be out there in the stars, only hanging tight for mankind to find them. To address this question, two American space experts, Jill Tarter and Thomas Pearson, began a project called the Search for Extraterrestrial Intelligence, SETI, in 1984. Known as the SETI Institute, it is a not-for-profit venture that plans to channel through vast transmissions to identify radio transmissions from space. The justification behind zeroing in on radio transmissions is their capacity to travel immense distances without getting dispersed or assimilated like other types of radiation. Due to this property, radio transmissions are bound to be detected by the 42 radio telescopes that make up the Allen Telescope Array, arranged in the rolling hills of California. Despite the fact that the SETI Institute has continually observed transmissions of these radio signals, no such signals have been identified for more than 30 years. Jill Tarter remains certain about the chances of success, expressing a desire to engage Earthlings all over to become active participants in the mission for extraterrestrial intelligence. All of this happened until recent reports from NASA exhibited that the James Webb Space Telescope spotted city lights from a planet near Earth. The JWST is the giant card played by mankind to acquire a better handle on the huge secrets in space. Launched in December 2021, it is known as the best infrared imaging telescope ever made by mankind. Equipped with the most advanced optical technology available today, the James Webb Space Telescope can look past the veil of cosmic dust to uncover the secrets of the universe. Its primary mission is to investigate the universe in search of the first galaxies and stars that were formed billions of years ago. The telescope is designed with some of the most refined optical technology of this current era, propelled by James E. Webb, a visionary NASA head who was a key backer for space exploration in the Apollo moon landing programs. At its core, the James Webb Space Telescope is built with an extraordinary array of instruments, all working together to provide unparalleled views of the universe. This includes a near-infrared camera, a near-infrared spectrograph, a mid-infrared instrument, and a fine guidance sensor that allows it to maintain its precise position in space. The giant mirror of the James Webb Space Telescope, made of 18 hexagonal segments, has been carefully designed to capture faint light from the earliest galaxies in the universe. It is designed to work at extremely low temperatures, allowing it to detect weak heat signals sent by distant objects. Since its launch, the James Webb Space Telescope has delivered on its commitment by uncovering the most distant and oldest galaxies ever seen. Its powerful instruments have provided new insights into the formation of stars, the development of galaxies, and the creation of exoplanets. The discovery of city lights on Proxima Centauri b is a crucial finding that adds to the growing body of evidence suggesting the presence of life beyond our solar system. While further investigation is required to confirm the nature of these lights, the James Webb Space Telescope has undoubtedly opened a new chapter in our mission to understand the universe and our place within it. Launched in December 2021, the James Webb Space Telescope is equipped with cutting-edge infrared imaging technology that allows it to peer through vast dust and uncover the secrets of the universe. Its primary mission is to observe the formation of the first galaxies and stars billions of years ago. However, its capabilities extend far beyond that. The discovery of city lights on Proxima Centauri b, the nearest exoplanet to Earth, is a surprising accomplishment that raises intriguing questions about the potential for intelligent life beyond our solar system. The bright light seen on Proxima Centauri b suggests the presence of an advanced civilization capable of creating artificial lighting. This discovery has significant implications for how we grasp the universe and the probability of life beyond Earth. Scientists are now focusing on the nature and origin of these lights, examining various hypotheses to explain this phenomenon. One of the primary objectives of the James Webb Space Telescope is to study the atmospheric composition of exoplanets by examining the thermal emissions and chemical signatures of Proxima Centauri b. Researchers hope to determine whether the planet has the necessary conditions to support life. The presence of gases such as oxygen, water vapor, and methane would be strong indicators of a habitable atmosphere. The James Webb Space Telescope's infrared sensitivity makes it an ideal tool for this investigation. Its ability to detect faint light signals in the vast darkness allows it to observe the thermal emissions from Proxima Centauri b and gather crucial information about its atmospheric properties. The telescope's alignment with the planet's orbital period enables comprehensive observations of both its day and night cycles within a relatively short time, capturing temperature variations on Proxima Centauri b. These variations are essential for determining its atmospheric composition. If the planet has no atmosphere, the temperature contrast between its day and night sides would be extreme, like a dark body. However, if it has an atmosphere, the temperature variations would be moderated, indicating the presence of atmospheric gases and potentially liquid water.